There are mountains of data to conquer. These mountains, unlike their counterparts in nature, continue to grow larger every day. My name is Corey Perville, and I'm the CEO for Core Data. I work with customers deploying data storage solutions in many different environments. Each problem and every challenge is different, and so are the solutions we employ to deal with them. I'm going to share some of our experience with you in an informative and entertaining way. It's commonly stated that data overall is growing at a rate of 30% per year. Compounded, that's a staggering amount of growth to manage. 75 terabytes in just 10 years becomes over a petabyte, over 1,000 terabytes at that growth rate. Effective methods must be found to deal with managing and protecting these staggering amounts of data. Core Data, an independent reseller of mid-range storage solutions, produced this brief video and the rest of this series to assist you, the IT professional, to deploy new technologies in highly effective ways. Together, we will conquer your mountains of data. Swimming pools hold large quantities of water. This one, for instance, holds almost 15,000 gallons of water, and an Olympic-sized swimming pool holds 660,000 gallons of water. Garden hoses, on the other hand, move a pretty modest amount of flow. If your garden hose averages about 10 gallons of water per minute, it would take you about 45 days to fill an Olympic-sized swimming pool. Similarly, if you have a terabyte of data in your storage array and you attempt to copy it over a 1 megabit network connection, it'll take about 2.5 hours to copy the data, assuming, of course, that your network connection isn't busy with other traffic. But what happens when you've got Olympic-sized storage requirements? When you have 50 or 100 or 500 terabytes and your copy time goes to 5 or 10 days or even a month and a half. This is when you might consider using snapshot and replication technology to move data between sites. It's a much more efficient way to manage your data in multiple sites than copying it whole. The power of snapshot technology is the Snapshot Engine and redirect on write technology. Nexan's technology uses the zettabyte file system, or ZFS, originally developed by Sun Microsystems as a high-performance file system for Solaris. It's a 128-bit file system, allowing for very large memory addressing. The technology for Snapshot Engine is referred to as redirect on write, an enhanced version of an older snapshot technology referred to as copy on write. Here is a simplified example of how the NST Snapshot Engine works. When new data is written to disk, it's written as a series of data blocks. After the data is written to disk, we start the first snapshot on the data as it sits. Notice there's nothing stored on the snapshot area yet, since nothing about the original data has changed. Also note, starting a snapshot takes almost no system resources, so you don't have an impact on performance or applications by creating multiple snapshots, even lots of them. Now, some new data, and updated data block B arrives. Instead of overwriting the old block A, the system stores the new data in a different location on disk and sets a couple of pointers. The memory pointer now points to the new block B, making it a current part of the file. Snapshot 1, however, stores a pointer indicating the old data block A. This is so the snapshot, when it's assembled from its pointers, always shows the file in its original unaltered state at the time the snapshot started. Snapshot 2 starts. You can have up to 512 shares and over 2,000 snapshots per share on the NST system. More data arrives with 2 updated blocks C. Pointers are updated, so memory, Snapshot 1, and Snapshot 2 all reflect the update. Performance is very fast on the NST since metadata such as pointers are maintained in high-speed protected memory. Now you see the current contents of the file, versions on disk in Snapshot 1 and Snapshot 2, all assembled from the unchanged data as originally stored, and pointers. Anytime a file is read, Whether the current contents are a snapshot, the file is reassembled very quickly from pointers, so your snapshots always reflect how the file looked at the time its snapshot started. Backup systems are able to use snapshots of data to copy the data to tape or another site without affecting the servers that are running. You create snapshots much more frequently than backups, since they don't affect server applications to do so. You can automatically perform a snapshot every 15 minutes if you wish. Storage systems, such as Nexan's NST Unified Storage Array, can automate snapshots, backups, and replicate data to another site, so it becomes very easy to completely protect your valuable data from problems. If your data is corrupted, you can easily convert the affected data back to the most recent snapshot, or go back to a point in time before the data was impacted and pull out single files. Replication works this way too. You either replicate synchronously, where both sites always match up with the same data, or asynchronously, where you push data to the other site and it gets there as quickly as it can. With synchronous data mirroring, you have absolute mirrored data, but data can only change as fast as the remote location can receive an acknowledgement. So systems like the NST use very fast system interconnects, such as SAS or fiber channel, to create synchronized data on two separate NST systems. For a metro cluster or wide area network, asynchronous replication works best. The NST supports both types of synchronization, so you may use synchronous mirroring for critical data that must be mirrored in real time, or asynchronous mirroring to mirror data off-site. The NST even supports many-to-one synchronization, so you can use one site as a replication site supporting multiple NST systems. With most backup systems, data reacquisition is a big problem. When your backup data is on a tape cartridge, you must read it off tape and back onto an available storage array first in order to redeploy the data. And this can take days or weeks when you're dealing with many terabytes of data. With remote asynchronous replication, all you need is an adequate network connection, and your applications are back up and running in minutes. Now, many backup software companies offer replication capabilities. They use local backup servers to run software which snapshot and replicates data between sites. And they support disparate storage hardware attached via storage networks. And sometimes this is a good solution if you've inherited a bunch of different hardware, all with different brand names. But if you have the chance, it's much better to perform snapshot and replication in the storage array. This is because you eliminate many performance bottlenecks between your application servers, the backup servers, and your stored data. And you eliminate complexity because you reduce the many different hardware and software systems which must be integrated, since they all come from different companies representing different management tools. And that can be very expensive. But the biggest expense with backup software is not the software licenses, it's the interdependencies which cause complex problems when you upgrade or change any of the components of your data protection architecture. For instance, your backup software vendor approves only certain server hardware, network cards, storage arrays, operating systems, network topologies, and their list changes for every version of the software they release. If you bring in new hardware, you have to make sure it complies. And if the software vendor brings out a new release, you may have to upgrade operating systems, application software, server hardware, and even your network cards to ensure it all works together properly. And that can be very, very expensive. If you consider all the requirements and costs for backup scheduling, data movement, compression, deduplication, and application agent software licenses, you can see the cost advantages of a smart storage system like the Nexan NST, which performs snapshot and replication right in the storage array. With nothing more than a couple of NST systems far enough apart, you have a complete data protection and disaster recovery solution, and it's all managed from a single pane of glass. And with price-correct storage attached, there's no need to deal with deduplication, a storage solution with slow write performance, premium prices, added complexity, and the fact that some data simply doesn't compress or deduplicate very well.
My whole experience with Nexan, I think it's always been one of surprise. I think, seeing the products in action, you're always surprised that the product can deliver what it can at such a low price point. My name is Larry Cho. I'm the network manager at Bates White LLC. We perform a lot of sophisticated statistical analysis for our clients, and a lot of that is very I/O intensive and memory intensive as well. We first discovered Nexan about 2 years ago, and we were looking at doing an upgrade to our existing storage system. The current pace that we were growing, our data just wasn't sustainable with our existing storage system. Being a small mid-sized business, we were looking at cost as being a primary factor, as well as reliability. So when we first looked at Nexan, there wasn't much that we knew about the company itself. We didn't know anything firsthand about how it stacked up in terms of reliability, the usability of the system, how easy it was to set up and administer on a day-to-day basis. It only took about 10 minutes to rack and stack it, and after that, there's probably another 10, 15 minutes playing around with it. And to be honest, I think I just skipped and I didn't even look at the manual when I set them up. So initially, when we first purchased the Nexan products, because we didn't have firsthand knowledge about the product and its reliability, we purchased it as an archive tier, kind of a second tier of storage where we could put inactive data. After running the systems for about 6 to 9 months, we really began to trust the systems, and we started shifting the way we looked at what we could store on these products. And we started actually putting in some active client data. And from there, it kind of spun off, and we looked at putting SQL storage data on there. And it's really grown for us into kind of a different product where it was originally archive data, and now it's it could be considered first tier in our SQL database instances.
Let's see how a Nexan NST storage cluster completely protects your data. Here's a typical backup solution with a local tape library to store the backups. Here's a typical second site for disaster recovery. Notice the second off-site tape library and backup server. This is to recover data from tapes at the remote site. Now you have a second set of servers to access the data and a second storage array to reacquire the data. And off-site tape vaulting or replication just to be sure your data is safe. Here are all the many different software licenses it takes to perform this sort of backup and disaster recovery solution. And the data reacquisition time to recover the data from tape to disk at the remote site could take days of load time if you're recovering the data from tape back onto disk before it can be used. Now, let's use the NST system to perform the same functions. Note, we'll use scripts or standard Microsoft Volume Snapshot Service, or VSS, to perform all the application agent functions. This is an industry standard approach rather than a proprietary backup solution to normalizing application data before a snapshot or backup is performed. Notice how the local and remote site backup servers disappear, and all of the associated software license costs as well. Now you only have to copy data from the NST to tape at the tape replication site. But most importantly, the data recovery time goes from days to minutes. With the NST, you've always got a usable image of your data on disk, ready to go. As your data assets grow, you'll want to re-architect your data protection strategies to better match with your data recovery goals, but it's difficult to do in many cases. You have existing systems in place which represent years of development time, and groups of employees who have years of experience with the many software tools you are employing. However, we usually see immediate customer returns from upgrading a backup software-based vendor solution to a storage array-based solution. And in almost all cases, you can continue to use the backup system and scheduler you already have. It's the expensive application agent and remote replication licenses you can eliminate and stop paying for expensive software. When you see the financial advantages to a storage system-based backup and disaster recovery solution, and then add to that the obvious advantages of much faster data reacquisition and data recovery times, and then add to that a substantial reduction in complexity and inter-system dependencies, the choice is clear. It's time to stop the flow of wasted spending. This show, Conquer Your Mountains of Data, is all about data storage and sharing our experiences serving the needs of our diverse customer base. Core Data, a data storage systems integrator located in Herndon, Virginia, has over 13 years of experience serving customers in commercial, civilian, intelligence, and military settings. We also specialize in the unique requirements of classified data, research and development, and high-performance computing environments. In affiliation with our sponsors, we hope to bring you useful analysis of the many different data storage challenges and solutions we encounter, and assist you, the IT professional, in finding new ways to solve new problems. It is our goal to help you, our viewer, conquer your mountains of data.